As we wrap up chapter 3, I want to do a little bit of review and touch on some things that are going to be good to review as you prepare for the final, as well as we move forward into this last unit. So we're going to start with the density curve, which is actually where we started this chapter with. And the properties that we had at the beginning of this chapter were that this density curve plots the possible values of the variable along that horizontal or x-axis. And then the height represents the probability for that value. So the smallest probability you can have is 0. So that means the lowest value can sit on the x-axis, but it can't be below that because we don't have negative probabilities. And then we've defined this that the area under the curve is equal to 1 square unit or 100%. So let's add a couple more properties here. And some of these might be review, some of these might be new. So the density or the median of a density curve is the equal area point. So if we were able to cut that area exactly in half in a 50-50 split, it's going to cut the area under the curve in half, which is hopefully what we remember from box plots in chapter 2, that median is a 50-50 split. The mean of the density curve is the balance point. So if I cut this curve out of a solid piece of wood or material and I balanced it on my hand, it's going to be the spot at which it's going to actually sit here and balance without falling off. So that'll kind of give you a sense of the mean. And then in a symmetric curve, like our normal distribution, the mean and median are the same. In a skewed curve, the mean is further out in the tail. So if your distribution is right skewed, the mean is going to be further to the right. So it'll be bigger than the median. If it's less skewed, then the mean is going to be on the left side in that left tail. And so the mean is going to be smaller than the median.